All right, today we're starting our next new unit. This is Unit 16, Probability. This is going to be our last unit of the 7th grade standards for this year. After this, we're going to move on and finish up the 8th grade standards we had worked on earlier this year. At the algebra ones, we have to go and finish up some other things as well. But anyhow, this is our last unit on the 7th grade standards, probability. So our title for today is Likelihood and Probability. And so go ahead and add that to your table of contents. Then flip to the next clean sheet of notebook paper. At the top of your page, write the title, Likelihood and Probability, and then the essential question for today, how can I describe the likelihood of an event? Hit pause and set up your notes, and when you're ready to move on, hit play. All right, first, you can use words to describe the likelihood that an event will occur. And they range from impossible to certain, okay? Impossible to certain. You don't need to copy this down. Let's just talk about them. When we say something is impossible, an example of that would be if we're still in a slump, the playoff spot for our Wolves is impossible because they're not going to make the playoffs if they keep losing, okay? Unlikely. That means, for example, the economy is unlikely to recover this year. It could happen, but it's more likely that it's not going to happen. As likely as not, scientists say another earthquake in this region is as likely as not. That means that it could happen or it might not happen. It could go either way. Next, likely. An example, showers likely in the afternoon. That means that it's not 100% guaranteed to happen, but it is more likely than unlikely to rain this afternoon. And then certain, Congress is certain to pass the new tax law. So if something is for sure going to happen, that's when it's certain. So let's see if we can match these. Again, let's just go through them together. And, okay. You will go swimming on a hot summer or a hot day this summer. Which do you think that would be? Jot it down. It would be likely. Likely. Not certain that I'm going to go swimming. Because I might not want to go swimming or I might not have the time. But it is more likely than unlikely that I'll go swimming on a hot day this summer. I'll say. Not writing. There we go. Okay, so I'll say likely. Alright, next. There will be children wearing costumes on Halloween. What is that? That is certain. For sure, you will see children in costumes on Halloween. Your hair will grow 5 inches in one day. Is that possible? No. I know some of you are going to want to argue that it could happen. No, it's impossible. 5 inches in one day doesn't happen. All right, you flip a coin and it lands heads up. What is that? That is going to be as likely as not. Because it could happen, it could not happen. It's the same chance either way. And then last, a student in your class will become famous next year. What is that? It is unlikely. It could happen. But more than likely, it's not going to happen because so few people end up becoming famous. Okay? All right, so what word best describes the likelihood that 2 people sitting next to each other on a bus have the same birthday? Is that certain, likely, as likely as not, unlikely, or impossible? Well, for 2 people to have the exact same birthday, that means out of 365 possible days that they could have been born, they have, or I guess we could say 366 if we count February 29th. They would have to have the same one. That is going to be very unlikely. Okay. All right, this is what I want you to copy down. I had you hold off on it earlier. This is what I want you to copy down. Copy this entire slide. Okay. The probability of an event is a number from 0 to 1 that measures the likelihood the event will occur. The closer the value is to 0, the less likely the event is. So 0 means impossible, and then the closer the value is to 1, the more likely it is. 1 means certain. And we're going to have those numbers as fractions, as decimals, and as percents. And I do want you to copy all three. So copy the terms and the probability values as well as this definition up here. Hit pause and finish copying that down. When you're ready to move on, hit play. All right, here's an example. So if we were going to say the probability for stripes, looking at these flags, how many have stripes? 1. How many total flags are there? 4. So that would be 1 out of 4. To convert a fraction to a decimal, we divide. To convert from a decimal to a percent, we multiply it times 100. So this is the 3 different ways we could write the probability of stripes. And this is probability notation. You're going to see P and then parentheses and something in parentheses. What that means is P, the probability of whatever's written in the parentheses. So what would be the probability of a striped flag? We already see that they found 0.65 as the probability. So for the likelihood, we say that's impossible, unlikely, as likely as not, likely, or certain. It is likely because the probability is 0.65. That is greater than 0.5, so it's more than half. That means it's going to be likely, more likely than not likely. There we go. Likely. Why is it not working today? There we go. Likely. What would be the probability of getting a triangle? They've already found that it's 50%. So 50% means the likelihood would be as likely as not. Okay? And then 1/5. What about 1/5? What would that be for the likelihood? That would be unlikely. And then next, let's just convert between our fraction, decimal, and percent. So if I have a decimal, I know I can go ahead and write that as a fraction with its place value as the denominator. So 6,500 would make it 65 over 100. And as a percent, it would be 65%. And I could definitely simplify this as well. I could simplify by dividing by 5. What would that give me? 16 over 20? Is it 16? Hello. Where's my brain? 65 divided by 5 is 13. Wake up. Okay, so 13 out of 20. My bad. All right, next, 50%. We know that would be 1/2 or 50 over 100, which is 0.5. Okay, 1/5. That would be 0.2 if I divide it, which is 20% as a percent. So make sure you feel okay with converting between a fraction and a decimal and a percent and knowing the meaning of the probability that relates to the likelihood. All right, I feel like we're okay. We need to do this one. So this is going to help us make a prediction then. An airline believes that the probability of a passenger being a no-show on an afternoon flight is 10%. So 10%, we know that's 0.1. That means that they expect 1/10 of the ticketed passengers to not show up. Do this example with me in your notes. So we have 2 different flights that are overbooked, and we want to figure out on which flight should the airline expect to have more empty seats. So if we know that 1/10 are not going to show up, how many tickets were sold for flight 1? Do this in your notes. So flight 1, of course, my word is not writing. Sometimes it makes me do this and sometimes it doesn't. I don't really know. Okay, so for flight 1, they sold how many tickets? 210 tickets. So I'm going to multiply 210 times 0.1 to see how many of the no-shows we should expect. And when I do that, 210 times 0.1, that's going to be 21 people, PPL, people are going to be no-shows. Okay? What about the flight 2? Flight 2, they they sold 330 tickets, so we would expect how many to be no-shows? We'd multiply times 0.1. 330 times 0.1, that would be 33 no-shows. So our question says, on which flight should the airline expect to have more empty seats? Well, if they have 200 seats on flight 1, if we subtract 210 tickets, the number of tickets sold, minus the 21 people not showing up, how many seats are we going to have filled, or how many people are going to show up? We would say 210 minus 21, that would be 189 people on board. Really? This is going so well today. I don't know why my board is being difficult. 189 people on board. So how many empty seats would I have? If there's 200 seats on the airplane, I would have 11 empty seats. On flight 2, if I had sold 330 tickets, 33 no-show, that means there's going to be 297 people on board. So how many empty seats? There's 300 seats on the plane. That means there's 3 empty seats. So which flight will have more empty seats? Flight 1. Okay. All right, the second thing we need to talk about is sample space. I'm combining 2 digits lessons into one for today. This is 17.2. Sample space. Go ahead and hit pause and copy these terms into your notes. You need action, outcome, and sample space copied into your notes. So let's go over those terms. In probability situations, an action is a process with an uncertain result. An outcome is a possible result of an action, and then the set of all possible outcomes is the sample space for the action. So let's look at an example of rolling a number cube. In this situation, we're rolling a number cube. The action is the process with an uncertain result, so the action would be rolling the number cube. An outcome is a possible result of an action. So for rolling a number cube, one possible outcome is 1, another possible outcome is 3, another possible outcome is 6. And then if we listed all the possible outcomes, we would call that the sample space. So for this situation, the sample space is 1, 2, 3, 4, 5, 6. It's just a list of all the possible results. Here's another example. If the action here we have, what is this, a pocket or something? I don't know. The action is choose one button. So you're choosing a button. The outcome is each possible outcome, each possible thing you could pick. So we've got these blue buttons, we've got these funky kind of buttons, whatever. The sample space would be all the possible buttons. And then the event is a group of one or more possible outcomes. The 4 buttons in this group satisfy the event as choose a white button, as we're going by color. So white is a possible event. Blue would be the other one. Okay, so look here. The band director chooses one trumpet player at random to lead the band in the holiday parade. List all of the outcomes in the sample space for this action. How many outcomes are in the sample space? So the action is we're choosing a trumpet player to lead the band. So our sample space would be just a list of all of these kiddos' names. I'm not going to write them down. You can see them. James, Jenny, Raul, Seth, Sarah, Maria, Jenny, and Julie. That is the sample space, all of those kids. How many outcomes are in my sample space? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 outcomes in my sample space. And that would just be the list of all of these different children who play the trumpet. All right, last example, we are going to label action, sample space, and event. Which is the action? It is playing the game. Which is the sample space? This last one, win, lose, or tie. And then the event, one of the possible outcomes would be winning the game. So, action, event, sample space, event.